What if the universe stopped expanding? As it's written in Revelation, time would stop. But let's be more precise. The universe is expanding everywhere. Its size increases at any given moment. So our question is better phrased as what happens if the expansion slows down and even reverses? What if the universe stops expanding and begins to contract? He thought that the only way to explain the increasing speed of galaxies' recession was that the intergalactic space itself was repelling the galaxies, pushing them apart. If the dark energy suddenly disappeared, galaxies would stop accelerating, slow down and start falling towards each other. Astronomers would quickly notice that something strange is going on. Our world would start to resemble a fried egg in slow motion. What would happen next depends on whether the neutrinos are their own antiparticles. If they are, the matter in the Big Crunch would literally boil, releasing enormous amounts of energy. What would the observable universe look like in this case? To answer this question, we need to figure out what would happen to the cosmic microwave background. Will the universe ever stop expanding or even begin to contract? What do scientists think? Most astronomers agree that the universe won't stop expanding anytime soon. They believe that dark energy will keep pushing galaxies apart for the next 10 to the power of 100 trillion years. But if the expansion slows down, it would become noticeable within the next 4 billion years. That is how long it will take for the slowdown to affect the orbits of stars and then for the first stars to go out. But there are other theories that are less popular but no less interesting. One of them is the cyclic Big Bounce model, according to which the universe goes through repeated cycles of expansion and contraction. In each cycle, the Big Bang is followed by the heat death and the Big Crunch. Another similar model is the oscillating universe model, which says that the universe periodically bounces off the walls of a higher dimensional space. Currently, the cosmic microwave background fills all of space and its temperature is about 2.7 Kelvin. And don't forget to subscribe. Thanks for watching. See you next time. In the contracting universe, this background would become highly distorted. All parts of the universe would get heated up to unimaginably high temperatures. The photons of the microwave background would acquire enormous energies and would interact with each other to produce intense bursts of gamma radiation. Gamma rays would ionize atoms and molecules that might exist in space at that time. In other words, the universe would once again become opaque. At the same time, the intergalactic medium would be compressed and heated so much that nuclear fusion reactions would begin in it. All elements heavier than hydrogen would be synthesized in those conditions. The most important change in the observable universe would be that all distant galaxies would become blue-shifted and then would reappear in the sky as if they were close to us. Also, they would become incredibly bright because of the high redshift. Stars would seem to move in reverse, following a path that is the mirror image of their path in the current universe. Otherwise, a gigantic black hole would form in the center of the galaxy, attracting all the matter around it. A lot of stars would be destroyed during this collision. The remnants of stars would form a dense cloud of plasma in the nucleus of the new galaxy that would shine brightly for millions of years. After the collision, the new galaxy would begin to fly towards the beginning of the cosmic time, where the Big Bang took place. The observable horizon would shrink, approaching the size of the Milky Way. Then the stars that exist today would collide with each other. Along with the merging of galaxies, the frequency of merging neutron stars and black holes would sharply increase. This process would release huge amounts of gravitational waves. Near the end of this process, the observable universe would resemble a giant accretion disk around a supermassive black hole. In both cases, the entire mass of the Big Crunch would eventually be captured by the central black hole. At this stage, the Big Crunch would resemble a giant accretion disk surrounding a supermassive black hole. The radius of the disk would rapidly decrease as it was pulled inward by tidal forces. When the last stars and gas clouds are destroyed and turned into dust, the universe would reach the heat death. The speed of galaxies' recession would decrease until they began to fall towards each other like plums in a plum pudding. At the same time, the night sky would get darker because all the light coming from the receding galaxies would get blue-shifted. First, the sky would lose its reddish glow. Then blue light would begin to dominate. Ultimately, the universe would turn black and an infinite number of bright points of light would appear in the sky, each of them representing a galaxy. With every passing moment, more and more galaxies would approach each other and merge. At the same time, the brightness of individual galaxies would increase. Many stars would be destroyed during collisions between planets. In addition, the number of merging neutron stars and black holes would increase dramatically, leading to a sharp increase in the frequency of gamma-ray bursts. They would spot that the expansion of the universe has slowed down. Then they would realize that some unusual things are happening with distant galaxies. In this case, all galaxies would begin to move towards each other at an ever-increasing speed. But before the galaxies begin crashing into each other, our sun would have other problems to deal with. The fact is that dark energy makes stars slightly unstable. If it disappears, many stars, including our sun, will be shaken off their orbits and flung into interstellar space. If the sun finds itself too far away from the galactic core, it will leave the galaxy. Meanwhile, the Earth, along with other rocky planets, would most likely remain in orbit around the sun. Since Mars is the closest planet to Earth, it would become the main target of asteroids and meteoroids that have lost their orbits. After several million years, all solid bodies in the solar system would either crash into each other or into the sun. The only survivor of this apocalypse would be a cloud of dust and debris. The thing is, dark energy makes the light coming from distant galaxies highly redshifted, which makes them look more dim. If the dark energy disappears, these galaxies would instantly become brighter. However, there would be no way to find out what exactly happened unless we can detect changes in the cosmic microwave background, which is the oldest light in the universe. The cosmic microwave background is a snapshot of the universe as it was just 400,000 years after the Big Bang. Any changes in this background could hint at some new physical processes that occur in the universe. This period would be marked by an increase in the number of galaxy collisions. The rate of star collisions would increase too, which in turn would boost the rate of star formation. The frequency of gamma-ray bursts would also increase since the number of merging compact objects such as neutron stars and black holes would rise. Besides, the big black holes would grow very fast as a result of absorbing large amounts of matter and merging with other black holes. Scientists estimate that if dark energy disappeared, it would take about 40 billion years until all galaxies merge into one giant galaxy. This process would be accompanied by multiple collisions between black holes at the centers of galaxies. Mergers of supermassive black holes release huge amounts of gravitational waves, which are ripples of spacetime. In other words, after the dark energy disappears, the night sky would be filled with powerful bursts of gravitational waves. Such events would repeat over and over again until the very end of this process, when all matter and all energy in the universe would eventually fall into one infinitely massive black hole. This doomsday machine would be surrounded by a swarm of other black holes of smaller masses. This final state of the universe is often referred to as the heat death or the Big Crunch. Later, this idea was picked up by Albert Einstein, who added a cosmological constant to his equations of general relativity to make the static universe fit observations. However, in the late 1990s, two independent teams of astronomers found that distant supernovae were even more redshifted than expected. This means that the expansion of the universe was not only taking place, but was even accelerating. This discovery led to the idea that the most plausible explanation for the accelerated expansion is a new repulsive force caused by a hypothetical substance that permeates all of space. Because it acts in opposition to gravity, this substance was named dark energy. The exact nature of dark energy remains unknown, but scientists tend to believe that it makes up roughly 70% of the total energy content of the universe. I know it sounds like doomsday scenario, but for now this is just a science video. We'll try to find out what would happen step by step. Let's go. First of all, why does the universe expand at all? And how does it accelerate? In 1929, American astronomer Edwin Hubble discovered that all galaxies are moving away from us, and the farther away they are, the faster they recede. This observation is known as Hubble's law. It can be expressed with the equation v equals h naught times d, where v is the recession velocity, d is the distance to the galaxy, and h naught is the Hubble constant. When we look at distant galaxies, we see them as they were in the past because light takes time to travel. For instance, if a galaxy is 10 billion light-years away, we see it as it was 10 billion years ago. By extrapolating Hubble's law back in time, we can assume that all galaxies were once close together and then they started moving apart as the universe expanded. In the early 1930s, the Swiss mathematician and astronomer Fritz Zwicky first coined the term dark energy. So what if the dark energy vanished overnight? The simplest way to neutralize the cosmic repulsion is to reduce the amount of dark energy in the universe or change its properties. Here's another question. Would this scenario be noticeable on Earth? The answer is yes. Now, let's imagine that dark energy didn't just disappear, but changed its properties so that instead of accelerating the expansion of the universe, it began to slow it down. In about 40 billion years, all the galaxies would merge into one giant galaxy, the Big Crunch.